start the recording and then we can get started with the session. Okay.
Recording in progress.
Okay. So a nice useful feature of Python is Python, or for that matter any programming language, even shell scripting, is the concept of function. Function is nothing but, as the name suggests, right? You're writing some code which achieves certain functionality, which gives you certain functionality. We call that code block as a function. Now, what is the advantage of function is you write that function once, which means you define a function. You can use it any number of times, anywhere, wherever you need. Right? So it helps you to reuse some of the code that you're writing, and it helps you to make your code more modular. Modular in the sense you break down your big chunk of code into related components, right? Let's say you are solving a big problem where you are reading some data from some config data from files, and then you are connecting to certain network devices, reading some data from files. Processing. The data to put in desired format, and then go and use the processed data to carry on some config on the devices. Right? Let's say these are the things that you need to do as part of your automation activity. Now, you see clearly there's a distinction, right? This has something to do with files, file operations. We call this as file IO, file input output. This is the data which you read is in the form of text. So we process them as strings and then extract certain data, push them into some other list maybe, or a dictionary, create a dictionary, right? Data structures, string formatting, and so on. Right? The related mostly it will be string or number manipulation. Finally, connecting and configuring, connecting to and configuring the devices. So these are the logical units of the task, that the big task that you're trying to achieve. So obviously you'll write a function, some functions here, you'll write a functions here, you'll write functions here, right? So that your code looks neat. It's not just lying all over the place. There are functions which will do the file IO operations and return the data. Then these string formatting functions take the data which is returned by the file IO functions, and then they process the data, and then they pass that data to the other functions which will take that data and then go and configure. Right? That is broadly the use of functions. Right now we are looking at how to define functions, how to use them. Later we'll be doing somewhat use case similar to this, right? When we discuss the other things, how to connect to devices, etc. Okay, so that is where we are. We have seen an example where we define a data, we define a function, and then how we call that function. Now this function can be used for many other data sets, not just for the data set which we initially, this is the data, right? So we wrote a function called as calculating average. So you give marks, I can calculate marks, average marks. You give me something else, I can calculate the average of that something else. You give me taxes, tax amounts, I can calculate the average of, and so on. And that is the reusability part that I'm talking about. And the modular aspect is this. You see, all the code that is required for calculating the average of a given number of given list of numbers is nicely sitting in this little block called as function block, which starts with a keyword called as def. Right? You say def, give some name, and tell what is the data that you'll be passing to this function, and does this function return any data back. Then calling the function is like this. Use the function name, pass whatever data you want this function to process, and if at all it is returning any values, you capture it in a variable so that you can use it. Okay, that was a kind of recap for functions. We'll move on. Now, typically when people talk about functions, right, they talk about functions with mandatory parameters. Then functions with default parameters. Functions with variable number of parameters. Okay. What exactly we mean by parameters and what exactly is this? We'll see. Okay. Now, let me define one small function. Def say hello. Right? This function takes a name and then says hello. That's all it does, as simple as that. Right? Since it says hello, whatever name we pass to it, we're calling it as, let's say hello. Right? Now, if I have to call this function, if I call like this, will it work? I've defined my function like this. I'm calling my function like this. Will it work? Let's see. cd -3 yes. And then it says say hello. That is the function call is missing one required positional argument called as name. So it saw this name, say hello, went here, it said oh, say hello has been defined here, but it is expecting some name to be passed, some argument to be passed, but we are not passing anything here. Right? So it is throwing an error. So the proper way to call it is some name, some string that you need to pass. Okay. So functions with mandatory parameters is nothing but, yes, if you have defined a function, we call this as parameters, right? Parameters as in we are parameterizing, means converting the function's code into variables, so that if I pass my name here, it will say hello my name. If you pass your name, it will say hello your name. Right? The other way is hard coding the data. I can remove this and say hello Nagraj. Now, if I call this 100 times, it keeps saying hello Nagraj. right? Pointless, right? We'll be taking different inputs. How let's try to think of a similar thing. There's a function which takes some VLAN numbers, goes and configures it on certain router. Instead of passing those VLAN numbers here as parameters, if I fix them, okay, configure VLAN 0, VLAN 1, VLAN 2, and so on. That's all it'll do. How many ever times you call this function, it'll configure only those VLAN 0, 1, and 2, which is not what we want. We want to make it generic. So we say we parameterize it. Right? So we can say config VLANs on what? On some device. List of VLANs. On this device, go and configure this list of VLANs. On device. Okay. Now, when I'm calling this function, obviously I have to pass what is my device. Say router 1. Okay. Simply, it means that when we say functions with mandatory parameters, if some parameters have been passed when the function is being defined, then when you are calling the function, you are supposed to pass those values. And here we are defining and we are saying, yes, you will be given one device and you'll be given a list of VLANs for you to work on. That's what I promised him when I'm defining him. But when I'm calling him, I'm not giving him anything. Suppose I don't give these things here. Then he is confused. He doesn't know what to do. He throws an error. Right? That is what we mean by mandatory arguments. There is one more known as keyword arguments. Functions with keyword arguments. Now, some places I'm calling as arguments, some places I'm calling as parameters, right? Do not get confused. Both are one and the same thing. When I'm defining the function, these are like placeholders, correct? These are like placeholders because in this, a device details will be passed. In this place, a list of VLANs will be passed. So these are like placeholders. So when you define the function, these placeholders, we call them as parameters. When you are actually calling the function, you will be passing the actual values for the parameters, which will be substituted in place of parameters. We call this as arguments. That's all. This is the difference. Here, these are called as parameters, function parameters. When you are calling the function, the data that you pass, we call it as arguments. Okay, but most of the times people will be using these terms interchangeably. That is fine as long as you understand the meaning. Okay. Now we can define another. Okay, let's see. Let's execute by calling this function. Okay, so the function says, okay, I'm going to configure these VLANs on this device. Right? Later it will go and call the code to configure that. That's a different story. That's a story for another day. But seemingly the function is doing what we are expecting. Right? Suppose I forgot what is the proper way to call this function and ended up calling it like this. First I passed second parameter, then I'm passing first parameter. Right here, the order of this arguments should be device followed by list of VLANs. But some guy forgot and he's calling with list of VLANs followed by device. Do you think will it have any impact? Or will it continue to function the same way? What will be the output in this case? Let's see. Okay. The first case, it's saying on this device, I'm going to configure these parameters, these VLANs. The second case, it is saying on this, R1 will be configured. It's not making sense, right? So that's why this happened, because the position of these arguments have been interchanged. Okay, the position of these arguments has been interchanged from the time they have been defined and from the time to the time they have been used. To prevent this kind of thing from happening, we if we are very specific about the order in which we pass these values, we define the function with, we can call this function, we can make this function call with something known as keyword arguments, right? Now, for some reason, I need to call like this. So I'll give this name. Okay, I'm passing these values first, but go and put them in this. And when you go to this function, take these values, put them here. And then take this value, put them here. Now, with these arguments, you are associating a keyword. That's why we call them as, okay. That's why we call them as keyword functions with keyword arguments. Now, this will mess up your functionality, but this will not. Right? This behaves as normally. On device R1, these VLANs will be configured. We get the expected output. Okay. Now, what is the use case for this? There are some cases where you have a mix of both positional as well as keyword arguments. Right? In such cases, the positional arguments have to come first, followed by keyword arguments. I know there is a lot of technical jargon that is going on here. Let me show you with an example. So let's say I said that first value should be placed in list of VLANs. Second value, yeah, I know. Since this is list of VLANs, we might think that, okay, whatever is remaining should go into device. But it doesn't work that way. It says positional arguments follow keyword arguments. Positional argument. This is treated as positional arguments because I'm not associating a keyword with this. Follows keyword argument, which is not allowed as per the Python rules. So you should first have all the positional arguments. Later, the keyword arguments can go. And the order of keyword arguments can be interchanged because they are keyword arguments. And they will not get confused. These values will go and sit here. The other value, if we say twice, this will go and sit here. Okay, that's all. Mandatory arguments are like, yeah, they can be every argument that is every argument or every parameter that is being defined can be thought of as mandatory arguments, right? Mandatory arguments, we call them as okay. Ideally, we can We call them as mandatory because if a function has been defined with some parameters, when you're calling the function, you are supposed to pass them. In that sense, we call them as mandatory. Yes, to answer your question, they are, if they are not used with the keywords, they become positional. Okay, then we have something known as default. Right? Default arguments. Okay. I have a function like this. A device will be passed. A list of VLANs will be passed. Suppose whoever is calling this function, he doesn't pass the list of VLANs. Right? Then at the bare minimum, at least VLAN 0 and 1 should be configured. That is the rule. Let's say the requirement. Right? If you get the list of VLANs to be processed, to be configured, you configure that. Let's say you don't get the list of VLANs, at least go ahead and configure VLAN 0, VLAN 1. Okay, suppose that is the requirement. How do you write such a function? Okay. We write it the same way. Define config VLANs. It will accept two parameters. First one is device. Second one is VLANs. List of VLANs. But now we'll say this list of VLANs, at the bare minimum, it will contain 0 and 1. Right? By putting the values here itself, in the function definition itself, you say I'm putting the values. And then I'll say the rest of the function body remains the same. Right. Let me name these functions differently so that it doesn't mess up the other thing. Right. Now I'm calling this. I need to call the function. Otherwise, it can't be executed. I'm calling this function with a device R1, but I'm not sure which VLAN should I configure. So I leave it blank. Let's see what happens. Let's say this is R2. Okay. Say I'm just calling this function with just the device, which is first parameter. I've not given the second parameter, but it is taking this as 0 and 1. It is taking this as 0 and 1 because here we have specified these values by default. We have assigned these values to this parameter by default. Have you unzipped the zip file which you received? Is there a document inside or just a VM files? Is there a Word document? Okay. Most probably you will see a username as full name as DevNet student, right? Is this the full name? And your username would be student. Password would be DevNet student. Okay, let me comment the other function call so that it won't be confusing. It will be less confusing what is happening there. Okay. If I do not pass any values for this, the default values will be picked up. If I pass, I'll say R3, configure VLANs 10, 20, 100 on this. Okay. So this is the concept of default arguments. If you suspect that yes, the guy who's going to call this function, if he does not pass the value, then your function should not fail. So you put some default values in place, provided it makes sense. Suppose the requirement is such that yes, if no data has been passed, bare minimum you configure VLAN 0 and 1. In such case, we can set them as defaults. This part is clear. Functions with default arguments. If you give one value for the list, what do you mean by one value for the list? You just override the first default value. No. It will not. See, this entire list is treated as one value, one variable. Okay? Either this entire thing will be considered or the default one will be considered. Probably here it is list, so it might be a little confusing. So let me take another simple string, this thing, F, say hello. So here my greeting. Okay. Then yeah, I think forgot to put the document in there. Yeah, these are your details. Student is the username. DevNet student is the password. Oh, I didn't give you. Yeah, these are the ones. So I'll put greeting. And by default, the greeting will be hello. And then print. Okay. So if I say hello, simply say Nagraj. Okay. Here also we need to follow the order. Non-default and default. Non-default should come first, followed by default. This is also for the same reason. Positional. So I'm saying say hello to Nagraj. So it says hello Nagraj. I've not mentioned what to say, right? It is by default taken from here. But if you say hello Nagraj with not hello, but say hi. So this is a hi Nagraj. Okay, I'm not sure what link is this. I'll let me check. You share the drive link one more time. Okay, got the concept of default parameters. If you define something with a default value, even if they are skipped, it will work. Yeah, please post it there in WhatsApp group saying this link is not working, so they'll check. Okay. Next concept is variable number of arguments. Some cases, right? Let's say you're connecting to two different devices. In case of one, it requires only two parameters or three parameters: IP address, username, password. Let's say on some other device, you have enabled SSH key-based authentication, which means you just need username. Password is not required. Right? In such cases, you just need to pass two values. Right? F connect to device. Device IP, username, password. Okay. Okay. But let's say there's another function, there's another type of device which you have configured SSH key-based authentication. So in such case, connect to device one. I only need device IP and username. I don't need password, right? Because SSH key has already been set. So I'll get keyless entry. Let's say there's a third function where the function requires 4 or 5 different parameters. In addition to username, password, it requires some mandatory authentication information. So you might have to pass 4 or 5 values. So you see, again, so to handle that kind of situation, you again need to write one more function. So you need to write one function if 4 parameters are coming. You write another function if 3 parameters are coming. If you have to write another function with 2 parameters are coming. This becomes a not very efficient, right? You are duplicating the code and for doing the same things just because the data is varying. Data should the data as in the values which you are passing to the functions. Since they are varying, you should not end up writing different functions to handle different types of data. Right? So there should be one common solution. To understand where this got inspired is take the simple print functionality. Take the simple print functionality. Say print I prints. Then you say I user. It says it prints. You say welcome, prints. You see, you pass 1, it works without complaining. You pass 2 values, it works without complaining. You pass 3 values, it works without complaining. Yes, link is not allowing access. Check in WhatsApp group. I'm not sure which link they have shared. And do not worry, I mean, focus on the class. You can, whatever we have covered, whatever we are covering is more important. Whatever we have covered, probably it is there in the link. Okay. That's what we are talking about. Now we have this function with 3 parameters. This should also work. This function with 2 parameters. This should also work. And I should not be duplicate. Like now, we do not have print 1 for printing 1 value, print 2 for printing 2 value, print 3 for printing 3 value. We do not have that, right? CCDA is nothing but DevNet. DevNet Associate, we call it as CCDA. It's Cisco Certified DevNet Associate. Okay. It is one common functionality called print, which is handling these cases. Same way, I should not have connect device 1, connect device 2, and so on. I should have one this thing. Okay? That is where we need to write the function as something which accepts variable number of parameters. How it is done is, we'll comment out these guys. Okay. I'll simply say star connection underscore details. Okay. So I won't be naming them as device IP, username, password. I'll simply say star. Normally we use the convention as args because these are known as args, arguments, right? But yeah, either I can do that or a more meaningful name, because I'm talking about connecting to the device. What I expect here is connection details. So I'll say connection details. If that connection details is device IP, username, password, it should work. If it is just device IP and username, it should still work. That's why we are putting this star here. What happens is, let's print them out. Print. Simply whatever you're getting in them. One device, and pass IP address. Okay. What it has done, it has simply taken those whatever details we are passing, it has simply taken them, it has wrapped inside a tuple. Okay. Now you make another call where you pass only 2 details. Let's say this guy 35 here or 35 here as SSH enabled, so you don't need password. You see, my function is not complaining. It works for parameters with 3 parameters. It also works with 2 parameter arguments. It works with 3 arguments as well as it works with 2 arguments. That is the function with variable number of arguments or parameters. Simply say star and give some meaningful name. What is the data that you're passing? Okay. Now you can have any combination of this. You can have combination of variable number of parameters as well as positional parameters. Obviously, positional parameters will come first, followed by keyword arguments, followed by your variable number of arguments. Okay, but then how do I use them? How do I use these details inside a function? You see how those details are coming to you? They are coming to you simply as a tuple. So how do you get? How do you break the tuple? For using for loop for item in connection details. Okay. Okay. In the first case, it has printed this is my IP address, this is my username, this is my password. In the second case, it has printed this is my IP address, this is my username. Now I'll be passing these values to my I'll be using these values to connect my respective devices. If I'm connecting to something where SSH is not enabled, I'll use username password. Where SSH is enabled, I'll use only IP address and username and so on. Okay, that's the concept of that is what functions is all about. Anyone, any questions? Was it too much using all this terminology? Positional. Yeah, there's a loop concept. I mean, this is like a temporary name that we use to refer to each element of this connection details tuple. It's like saying for each item, for each element in this connection details, print each one. First one is IP address. So in the first case, it is IP address. For IP address in connection details, do this. Okay. Let's see where we are. Functions, mandatory arguments we have covered, keyword arguments we have covered, default arguments we have covered, variable number of arguments we have covered. Now there's one more called as one more level of complexity where KW args, right? Keyword args with we call them as args and args. Okay. Yeah. Hopefully you will soon get the recordings. And yeah, this till whatever we have covered that has already been shared. And okay, probably that's what is there on the link, right? I'll get the link rectified so that you'll be able to download. But yes, today's thing also will be shared. Yes, we can combine. Yeah, I'll arrange for it to be shared. Because there will be certain situations where we have some positional arguments, and then after that we don't know how many values are going to come. Okay, functions return statement we have seen. We will use the return statement in case the function has to return the data back to where it is being called. Okay, there's one more concept called as object-oriented programming, which is a little advanced concept. So we'll not be going into much of its details, but I'll briefly explain what it is all about. Okay. Now, what we have done so far is let's say we are dealing with the problem of network automation, right? Where let's say we have to ensure that the device configs are backed up in case there is something happens to the devices, you have a config backup so that you can set up the new devices and then apply this configuration on them. Or let's say you have a device which is freshly inducted, you need to set it up with the basic startup config. Right? So these are kind of typical, let's say, the day 0, day 1 tasks. So which can be easily automated using Python, the next tool that we are going to learn, Ansible and so on. Right? So what we are dealing with here are a bunch of devices. Right? Most of the times we'll be working with devices, configurations. So how we are doing so far is we are writing this kind of code. We just have functions. We say, yeah, connect to this device. We define that we pass the details, connection details to this function. Right? But there's a better way of dealing with these things by treating your devices, routers, switches, firewalls as objects, which they are. And they are of course are real life objects. You treat them there and then do programming around that. Now, it may not be very evident in case of this network automation case. I'll take, let's say, banking example. Okay. You have a bank, some XYZ bank. For the function of this XYZ bank, what all you need? You first need customers. The customers will have some accounts, bank accounts. Right? You have customers will have bank accounts. Then customers will be taking loans. Customers will be taking credit cards. Then to manage all these things, you need employees. To supervise these employees, you need some managers, bank managers, and so on. Right? With all these people around, you have a software banking system. Right? Now, this banking system, when customers go, they get a different perspective. They get the customer's perspective. Right? When employees go and log in, they get their employee kind of view. When the manager logs in, he'll be able to see some privileged information, which probably the employers and customers are not able to view. So it is the same system. It is the same system depending on which object is, who is accessing it, has to present itself in a different way. Right? Now this problem can be solved either in this way, writing plain code, or it can be solved better by treating everything that we are seeing here as objects and doing programming around the objects. Right? Now, when I say object, what do we mean by object is customer is an object. Treat customer as an object. NTK, you're not able to hear. Others can hear. Okay. Okay. Probably that's a one-off issue. Can you try disconnecting and reconnecting? NTK? Or change your audio settings if you're just plugged in device or something. Okay. When we say customer has a state and he has a behavior. State is nothing but not the state in which he lives, but it is his attributes, his the facts about him. What define the customer, like his name, age, gender, his address, his job, his financial history. All this comprise of his state. Then the object's behavior talks about what the object can do or how the object interacts with the system. What can the customer do? He can deposit money, withdraw money, transfer money from one account to other account. He can take a new loan, close an existing loan. Right? So you're getting this? What do you mean by state and what do you mean by behavior? Now this can be defined for each object. You take any of the objects. Okay, glad it's working. You take any object, you can define the object by using its state and behavior. State is nothing but the facts, the details about it. Behavior is nothing but what he can do, how he interacts with the system. Now, once you define these, solving your complex banking problem becomes somewhat easy, right? You can put your logic, apply your logic. Now, you go ahead, implement these functionalities, how a customer can withdraw money, what all should happen in the background when it withdraws money, or what happens when it transfers money from one account to account. The amount should get debited from the account, from the source account. It should get credited to the target account. So there's a target account which is involved. So these interactions between these different objects are also taken care when you define it like this. Now, same way like manager can define as an object, and he'll have some attributes like name, age, gender, etc. We don't need manager's financial history because he's the manager of the bank. Right? But if he wants to take the loan from the same bank, probably he'll become the customer, and then that's when we need to check his financial history. That's a different thing. But under normal circumstances, if he's like just doing managing, then we'll not need. His behavior will be like taking care of escalation management, right? In case some employees are not very happy with the staff behavior, or they're not getting their service that they expect, they go to the manager. Right? So his behavior is going to be different. Same way, employees state and behavior is going to be different. You can even treat bank accounts as bank accounts, loans, credit cards as objects, right? Though they are not concrete, right? Now these are human beings. Customer is a human being, employee is a manager is a human being. They are in flesh and blood, so they are in concrete. They are concrete objects. But these are intangible objects. Right? Bank account, credit card, of course, is you will be able to hold it in your hand. Right? Loan, you can't see it. Right? It's an intangible kind of object. But still, even if they are like intangible, we can still treat them as objects, and we can associate certain state with them. We can associate certain behavior with them. Right? For example, like what is the state of bank account? The account number, current balance, right? Last 10 transactions. All these things can be defined as its this thing. And what will be its behavior? Account gets opened, it gets closed, it's transferred. Of course, transferred would not make sense in the case of banking. It gets opened, it gets closed, it gets disabled, enabled. And let's say there are no transactions for a year or 2 years, 3 years, at bank stipulated period. So we cannot close them. Let's say there's a huge amount of money lying around, or he owns us money and he has taken a loan and it disappeared. Okay. So you disable it temporarily. Again, let's say he reappeared, we let enable it. So these are kind of so that is the programming that you do by modeling your application in line with the real world objects is known as object-oriented programming. As the name suggests, our programming is centered around objects, is oriented around objects, object-oriented programming. Okay. Till here it is clear? Now, you just see this. I said all customers are one set of objects. All loans are another set of objects. All credit cards are another set of. All employees are another set of objects. Why we are calling them as they are like a group or set of objects? Because when they are treated as objects, they are all when we are treating them as objects, they all will have same kind of state and same kind of behavior, right? It's not possible that each customer behaves in a different way, right, with respect to these behaviors. Of course, here you have privileged customers and non-privileged customers. That's a different thing, right? If that is the case, then we'll be treating privileged customers as objects, non-privileged customers also as different objects with certain less privileges and so on. That's not the thing that I'm talking about. But when we say customer, every customer will have same state and same behavior. Same state as in not everyone will have same name, etc., etc. Same parameters. What we call as state and behavior is state is nothing but what defines the object, right? How the object is defined. To define a customer, we need to know his name, his age, gender, where does he reside, what does he do, what is his financial history, right? Means all the details which are relevant for the bank to associate with the customer. Behavior is what he can do, how he interacts with the banking system, for instance. That is at a high level. Now the same concept can be applied to other things as well. So now you see all the customers have similar kind of state and behave in a similar way. Right? So how do you define this? So there's a common set of attributes which define the customers and a common set of behavior which defines these customers. We call this common set of state and behavior as class. And each individual customer becomes object of the class. Right? Why we call them as class and object is, let's say you are given a big sack with few blue color balls, few red color balls, few yellow color balls, few green color balls. You are asked to classify them. You are just given a sack with balls of different colors, and you are asked, okay, sort them out, classify them. They didn't tell anything. What will you do? You're just given a bag full of color balls of different colors. You are asked to classify them. What will you do? You'll simply separate all the red balls into one group, all the green balls into one, all the yellow balls into one, right? So what you are doing, you are classifying them. What do you mean by that? You are associating a class with them. Right? All red balls is one class. All yellow balls is one class. All green balls is one class, and so on. Now, what is common between all yellow balls, all green balls, all yellow balls, for instance? That they are balls, first thing, and they are yellow. That behavior, we call it as, based on that common behavior, we say that yes, all these balls belong to a class called as yellow balls. Right? Same way, now classes can be defined as customer is a class. Right? Account is a class. Employee is a class. What are objects then? Customer 1, customer 2, customer 3, and so on. Same way, account 1, account 2, account 3, employee 1, employee 2, employee 3. These all will be objects of these classes. Customer 1, customer 2, customer 3 belong to customer class. Account 1, account 2, account 3, etc., etc. These are just names I'm giving. Again, when you go into customer, they'll have customer 1, he will have some name or some age, some gender, he resides in some place, etc. Customer 2 will be having some other name, some other age, some other gender, he'll be living somewhere else, etc. But we call them as objects because they all have the same kind of state and behavior which is defined in this class called as customer. Okay. Now 16 class.py. How we define a class? Let's say we want to define firewall. Right? Want to define a class called as firewall. We'll say it starts with a keyword called as class. Then the name of the class. What we want to define? We want to define firewall. Okay? By convention, when you are defining classes, you start the first letter with capitals. That's one of the coding practices. Okay. Now, what all properties this firewall should have? Right. It will have policies, rules, policies, this is what, let's say, defines the firewall. So when I'm creating a firewall, I need to know I mean, I need to know their rules, their policies, etc. So whenever you are writing class, right, you define a initialization function. But first you need to initialize. This is little complex, but let me see how best I can explain this. Okay. So I'm defining a class called as firewall. Now this any object like firewall1 who will be an object of this class, right? Be defined using this function called as initialization function, right? This function will initialize the state of different objects that we are going to create later. Here we are just defining a class, right? The structure, the outline we are defining. Right? So we are saying that when we say self, right? Self refers to the future objects which will be created. Let's say the firewall1. That firewall1 will have some rules, firewall rules, and some firewall policies. Right? These will be passing when we are creating a firewall1. Right? What are the firewall1's rules? What are the firewall1's policies? Now we'll be taking them and putting them in this self.rules is equal to this guy here, rules, which will be coming. Okay. If you want to take us a very simple example, class chair, right? We are defining a class called as chair. So we should right. When you think of a chair, what comes to your mind first? What is it made of? Right? Is it metal or is it plastic? Right? Material. Then it's how many legs are there? There are chairs with 3 legs. There are chairs with 4 legs. Num legs. Then what color is it? I'll come to the self. Then what color is it? Color of the chair. Right? Let's say these are the basic parameters. Okay. Now, I'll come to the definition first, but how we'll be using this to create, let's say, chair 1. How chair 1 will be created? We will use this class. We will say chair 1, it belongs to the class called chair. It will be made of wood, right? Because I need to tell what material it is made up of. So it will be made of wood. It will have 4 legs. It will be painted in, let's say, brown. Okay. These are we create chair 1. Then we'll create chair 2. Again, chair 2 belongs to this class called as chair. It will be made of steel. It has only 3 legs. I mean, 3 legs as in not the other way. I mean, they are arranged in such a way that the chair won't fall. It's painted in, or let's say 5 legs for extra stability in between. It's painted in black. Okay. This is the way we will be creating different objects by saying that, because these basic parameters define their state. What material it's made up of, how many legs it will have, what color it is. I'll come to that self thing in a bit. But to understand the self, right? I jumped a bit and then showing you how different objects will be created. This is the way you'll be creating. Ignore this also for the moment. Think that this is also not there. You just created a class chair as blank. And you have a rough idea in mind that yes, chair will have a material, it will have number of legs, it will have a color. Okay. Now, how will you tell in this class that yes, chair 1 should be made of wood, it should have 4 legs, it should be brown. Somehow we have to define this in class, right? Now this and this chair defines different objects. In this case, it is defining chair 1. In this case, it is defining chair 2. In some other cases, chair 3, chair 4, chair 5, chair 6. So when you are talking about chair 1, we need to refer this as, this is chair 1's material. This is chair 1's number of legs. This is chair 1's behavior color. This is chair 2's material. This is chair 2's number of legs. This is chair 2's this thing. Right? Like this, I don't know how many objects will be there. So I cannot go on saying this is chair 1's this is chair 2's this. So what I'll do, I'll say whichever object I'm describing, it is that guy's material, that guy's number of legs, that guy's color. Right? If I'm defining chair 100, this will be chair 100's material, chair 100's number of legs, chair 100's color. Right? Now that in a way, it is saying as, okay, if you are defining chair 1, chair 1's material, chair 1's this thing, chair 1's that thing, chair 2's material, chair 2's legs, chair 2's color. So what you'll say, whoever is being defined, it is his own, whoever is being defined, which means, let's say, chair number 56 is being defined. This is chair number 56 material. Chair number 56 is number of legs. Chair number 56 is, that is what we in short call it as self. Right? When you say self, whichever object is being defined, that guy becomes self. Now the self's material, self's number of legs, self's color. Right? Now the values which come here are the values which I'm passing here. And the values which I'm passing here, when the class is being created, they go and get passed in this place. So these are like placeholders. These are like arguments which we are passing to this special function called as _init, which initializes the state of a object of a class. Right? So inside this initial function, I have to say this guy is, whichever object is being created, his material. Now, which is the object which is being created? We are referring to this as self. So we'll say self dot material is equal to this guy, what we pass from here. Material. Self dot num legs is equal to this guy, which is we pass from here, from outside. Num legs. Self dot color is equal to color. right? That's why we call this as underscore underscore init underscore underscore. This underscore simply means that it is a internal function, and it will be used internally. We will not be seeing it, right? Accordingly, you see, when I'm creating this chair, I'm calling this chair, and I'm not calling this underscore underscore init, right? That's why we call it as internal. Self.rules, is it object or variable? It is, right? You're talking about this, right? Self.rules. This is a variable. Object will be like fw1. Sorry. fw1 is equal to firewall tool underscore list policy underscore list. This will be my object. This becomes my object. This is a variable. Now, to which does this variable belong? It belongs to self, which means if I'm creating F1, this rule belongs to F1. If I'm creating FW2, this rules belongs to FW2. Whichever object we are referring, this variables belong to him. That's why we refer them using the keyword self. Okay, in this case, it is this. Hope I could explain this complex concept to people who have not done any programming. One thing is you will not be extensively working with classes. So even if you have not understood or you've not understood fully, it is still fine. For now, you can ignore classes. You can focus more on the basics that we have discussed and the functions to a good extent. By then you will get quite a good hang of things in Python. Then when you revisit these classes, right, things will start making sense. Oh, okay, this is the way. Because if you see all the things like these are variable assignments, right? Functions, right? Whatever concepts we have used, we have discussed so far, we are putting them all together in this. This concept is to make code smaller as well as more intuitive. State and behavior using an example. It is to make more intuitive. Now you see, instead of writing a function called as define chair, I will say I'll be creating a class like this and using this kind of thing to create objects of this chair. Okay. Now. Let's say you are a furniture shop. You have written this chair class to describe the different types of chairs that you are offering. Right? Typically, you are building a catalog. Right? So this function here, the init function here, defines the state, because when you call the objects, when you want to create chair 1, you will call this class chair and pass wood to it, floor to it, brown to it. So the chair 1's color material becomes wood, chair 1's number of legs becomes 4, chair 1's color becomes brown, chair 2's color becomes chair 2's material becomes steel, chair 2's number of legs becomes 5, chair 2's color becomes black. So that is state. Fine. So state of chair 1 is wood 4 brown. State of chair 2 is steel 5 black. Now what is behavior? Now why you are doing this is, let's say you want to show a catalog, build a catalog of chairs, of all the chairs that you have. Right? So what you need for that? You need a function which can display the chair's details. Display details. What parameters required for you to display the details? All you need is a chair. Within a class, how is a chair referred? Using self. Class is an abstract concept. Class is we define to represent a real world structure or a logical structure. Functions get used inside a class. Now, for example, there's a class that I'm defining. Inside this, there's a function which I use to initialize the state of my class. This function is used to display the details of a chair and so on. And so this is the class. Class makes use of functions. Okay, so for displaying the details of a chair, all I need is the chair, which I'm talking about. So if I want to display the details of the chair, this will become chair. Now, how will I display? I'll say print a PVL self dot PVL. Self dot complex. So this we can think of as behavior. I mean, we cannot really think of when we say behavior, it's not the chair's behavior, but the object called chair's behavior. So one of its behaviors is, when I represent the logical chair in my software world, the behavior of this chair is it is able to display, we are able to display the details of the chair. Now, how do I do that? I'll say chair1 dot display details. Chair2 dot display details. Okay. So either you can start from here, you can start defining your class and then come and create objects, or you start imagining how you want to create your objects. What is going to be your class name? What is going to be your values? Accordingly, you can start working backwards to create a class. I feel this is a better approach because you have clarity on what details, what all details you will be using to create this object. Accordingly, you can go and pass them to your init function. Accordingly, you can initialize the class variable using this keyword. Accordingly, you can use them inside your behavior. But let's see it in running. You see, it says material wood, number of legs 4, class from. Okay. Now, this would be slightly confusing because here, you see, I'm in the previous lecture, we spoke about before this, we spoke about functions. Functions will have some parameters which become mandatory. And I'm here, I'm calling this without the mandatory function. So I might ask, how is this working? Right? this little jugglery which is done inside Python. The proper way of calling this function would be, right, I'll show you by commenting out these two lines. A proper way for me to call this function would be, you see this function belongs to this class. So I'll say chair, the class name, dot display details. Whose details you want to display? Object, chair1. You see the output is the same. Now this is making sense. This display details belongs to class. It is inside the class. So I'm saying chair dot display details, and this display details expects self. I'm passing that self, chair1, right? But this is somewhat cumbersome and not very intuitive. That's why they came up with, they rechristened this same way of calling this as simply call the object and call the function. It is understood that whoever is calling this function, he becomes self. Okay. I'm tempted to quote recent statements by a politician, but I don't want to make this political, so I'll restrain myself from using that term. Right? So this guy kills himself to annihilates himself and disappears from here and appears here. So that's the best I can. Yeah. By seeing this usage, you'll be able to appreciate what is self. Right? Now self is nothing but chair1. If I'm calling chair1, chair1 becomes myself. If I'm calling chair2, chair2 becomes myself. I guess that's more than enough for you to know about classes and objects. Right? The way you define your classes: class, name of the class, then def, init. Why we call this as init? Because it is a function which is used to initialize. But then why do you put this underscore? Because we will not be directly using it. You see, we are not directly using it. Right? Internally, this gets called. When we say chair and pass details to this, internally this is called. Right? Again, you see, this is class, but I'm calling it like a function by putting this brackets and by passing the values. So when we do that, internally it calls this. That's why this is called as init. Then what goes to init is this object and the data. This data goes and initializes the object's data. And then you can have any optional behavior in which, again, the self guy goes in and all the data is accessed via this self. Okay. I would say, yeah, you can ignore classes for now. Anyway, you got the concept. Now, since we took this simple object, we can extend this to this thing. You have a firewall, you have a list of policies, you have a list of rules. Yeah, I'll be sharing the document again, but again, it has to come through the portal. I cannot click here. But yes, you started getting the links, so you'll start getting them. That's about classes and objects. How much time we have? We have half an hour. So before we move on, anyone, any questions? Okay. There's another concept called as modules and packages in Python, right? We all would have heard modules and packages. We use modules and packages to enhance the functionality of core Python. Core Python, as in the thing that comes when we install Python, comes with certain pre-built functionality. Now we can enhance it by borrowing certain third-party modules and packages, which we call them as third-party libraries. Right? One classic example being the network libraries, right? Because this code, which is written by some guys to perform network-related operations, is not pre-built into Python. We have to borrow that code from someone and then put it in on our system and then start using it. Now that code is made available by them as third-party libraries. When we say library, is nothing but it's a collection of some folders. These folders, we call them as package. What is inside the folders? It is nothing but Python files. Right? So instead of we reinventing the wheel of how to connect to a specific device, how to execute your commands on that device, because ultimately the English like Python statements, Python commands that you give, if it has to go and execute on Cisco iOS, somehow they should be translated into Cisco iOS CLI commands. All that complexity, I do not want to keep doing every time again. I do not want to keep reinventing the wheel because wheel has already been invented. Someone has already written these packages. I'll use the wheel to build my own cart, right? Which will serve some purpose to me. As a concept of Python modules, right? To put it in simple terms, module is nothing but any other Python file, any Python program which is saved in a file with extension .py. Right? Now, if someone has done this, uploaded it somewhere on the internet, we can borrow it, we can use it for our purpose. Or even we have written these many 16, 17 and odd Python files, right? Even these are nothing but modules. If I want to use them as a module, I can always use them. And I'll show you how to use it. Library is a generic term. We call it as a library because library is the kind of, we can think of a collection of modules and packages. Right? So the hierarchy is like this. Module is any Python file containing any file, any .py file containing Python code. Package is collection or folder, a special folder. Containing modules. Library, we can think of it as a collection of some modules and packages. Okay. There's no specific term called as library, but in general, we call them as third-party libraries, which simply means the modules and packages written by someone else, which we borrow and use. Okay. Now we'll start with some built-in packages and then see how we can use our own packages, how we can write our own packages. Right? Now let's say you want to perform mathematical operation, right? You want to print the value of pi. Right? We can either do this. We can simply do Python. Print. What is value of pi? 22 by 70. It's not very accurate. Okay, how many digits? 142 8 something is come. But there is a pack module called as math. So we'll borrow that. Import math. In this module, we have value of pi, which is defined. I think it's capital N. Print dot pi. Let's see, I'm not able to. No module name math. It is small math. You see, I borrowed someone else's code from this Python file. I got this value called pi, which is defined there, and I'm able to print it. Let me print both these values to see which one is more accurate and which one is. Yeah, this is more accurate, obviously. 14159. 142 is a kind of approximation. Use get pass, it is not working for you. We'll just see. Yeah, from where we are importing. In the beginning, I mentioned, right? There are some things like, for example, print. The print function that we use, it's available as part of standard library, Python standard library. There's something known as Python standard library, which comes by default with the Python installation. So to use the things which are there in the Python standard library, you don't need to do anything. You don't need to install anything. You don't need to import anything. Right? It is available by default. So we'll start using all these functions. Now there are other kind of functions or values like this Python math.py, which is available in a module called as math, which has to be explicitly imported. And it has to be explicitly imported if you want to use it. But we don't have to see, I have not installed anything, right? So these things come with Python installation, but they are not part of the standard library. So we'll have to import them before we can use them. Then there is third category, which is not part of standard library, not even available with the Python installation. Those things we'll have to explicitly install and then import. Okay. Now, for example, in my case it works because I have it installed. In your case, it won't work if you say import name. See, it took a while to this entire guy. But if you put the same statement, you might get an error if it's not already installed. Okay, that is the concept of modules. You borrow modules using the import statement. And then whatever is available in that module, you'll be able to start using it. Okay. Now, math is a package. Math is a module, which contains some mathematical related stuff. We need to install packages. Yes, I think in our case it came with the Python installation. Can you just hold on? We are almost done. I'll enable it at the end, and then we can discuss. I'll quickly show you how we can, let's say, I'll write my own module, right? I'll call this, I'll rename this as my_module. In this, I'll define a dictionary, my I'm just declaring variables. I can also have functions. Def display. That's it. I'm not doing anything here. I'll write another function on my module dot py. And in this, I'll say import my import okay, that will be a problem because I'll have to remove the number. And this is my module. Okay, see, this is my the module, some Python file which I have written. I want to use whatever I put in here, the data, the functions which I've defined, I want to use somewhere else. So what I'll do, instead of writing them there again, I simply call this. Now I'll say print my module dot name. I guess it doesn't have one. It's here at the same level. Okay, I'll see what is happening here. Cannot import name, impression from why does it I can't import? It is able to identify this. Fine, I'll check this. We are almost close to this thing, so we can take any questions. The modules. I hope you understood the built-in function modules like math. We'll just see how we can work with this thing. Yeah, I will stop recording.
Recording stopped.
Yeah, we can ask questions.